Hello friends, welcome to the Retina imaging channel again. Today we are going to present a new video which is called Directional OCT. So what is Directional OCT? To answer that question, let us see how the OCT has evolved over last decade or so. Initially we had time domain OCT which had low resolution and penetration. The time domain OCT evolved into spectral domain, SSOCT and enhanced depth imaging tools. These enhancements in time domain OCT were a result of improvement of hardware and the software of the OCT system. However, consider a scenario that if we utilize the optical property of retina to image the retina better, then what would be the result? The result will be directional OCT. So what do I mean by utilizing the optical property of retina here? So let us see in the next few minutes. So this is the basis of directional OCT. We know that the retina is not flat. It's a curved structure on the back of the eye. So when the light of OCT camera falls on the retina, it's not always falling perpendicular to all the points of the retina. So there is a directional change in the incident light falling on the retina. So what is the meaning of directional reflectivity? So let us consider the structure of macula. We note that the layers of the retina which are traversing the thickness of the retina are mainly photoreceptors and Muller cells. So when the rods and cones are reaching towards the fovea from the entire retina, the rods and cones at the macula are oriented in a slanting pattern towards the fovea. The retinal layers at the fovea are vertical. However, when we move away from the fovea, the layers are slanted, and then again in the parafovea and peripheral retina they become almost vertical. So this is a Z-shaped pattern of cells where the foveal arm is vertical, peri and parafoveal areas are slanted, flat, and then again in the periphery it becomes vertical. So the directional OCT utilizes this property of retinal anatomy which is called directional reflectivity. Directional reflectivity means that a layer is best imaged when the light falling on it is as much perpendicular to it as possible. So consider these three rays of light. The middle one is falling perpendicular to the center and it will image the central part perfectly. However, the light demarcated as green here for the sake of understanding is falling on the part where it is not that much perpendicular. The light marked in green here is more perpendicular to the opposite side than at the position where it is falling. Similarly, the light marked in red is not that much perpendicular to the point where it is falling. Rather, it is more perpendicular to the opposite side of the retina. So this is the basis of directional reflectivity. If we see this green light which is falling on the left corner is more perpendicular towards the other side, and it will image the other side or the side highlighted on the schematic diagram of macula. Red light falling here will be more perpendicular to the area of retina highlighted in the schematic diagram. So consider the practical scenario. This is a dilated pupil. The camera light of an OCT system can fall right through the center of the pupil. It can also fall on either sides of the dilated pupil. So what happens if it does so? This is an OCT image with central pupillary light entry. We see a normal macular anatomy. What happens when the pupillary light entry point is shifted temporal as shown by the cross here or the light ray marked in green? Do we see any change in the anatomy of macula on OCT? Yes, we do see a change. What we see here is outer plexiform layer is looking hyperreflective on the nasal side, on the opposite side of the light entry point. Similarly, if the light entry point is shifted nasally as shown by the cross at the pupil and the red light beam, what we see here is that the outer plexiform layer on the temporal side becomes hyperreflective. So let us see the images again to understand them clearly. This is an image taken with central pupillary entry of light. We get uniform ONL or uniform OPL on both sides of the fovea. When the light entry point is shifted temporally, what we get here is as shown with the yellow rectangle. The nasal ONL appears to be thinned out because of hyperreflectivity of the OPL, and when the pupillary light entry is shifted nasally, the temporal ONL appears thinned out because of the hyperreflectivity of the temporal OPL. So these are the three sets of images which we were discussing in last couple of minutes. So what is happening here? Is the OPL becoming hyperreflective or ONL becoming thinned out when the pupillary light entry point is shifted nasally or temporally? No, it's not. What is happening here is that Henle fiber layer is getting visualized when we are shifting the pupillary light entry point from central position to nasal and temporal areas. So when the pupillary light entry point is central, Henle fibers layer is not visible because it is iso-reflective to the ONL. However, when the pupillary light entry point is shifted temporally, the nasal Henle fibers layer becomes visible or hyperreflective and it is seen distinctly from the underlying ONL. Similarly, when the light entry point is shifted nasally, the temporal Henle fiber layer is becoming visible distinctly from the underlying ONL. So this is a normal phenomenon which is happening here. In standard scenario, Henle fiber layer is isoreflective to ONL and it cannot be visualized with standard commercially available OCT systems which we have now. But it becomes hyperreflective opposite to the offset light beam at the pupil because of its directional property. And this directional property of Henle fiber layer is the basis of directional OCT. So what are the implications of this directional OCT and directional property of Henle fibers layer? If we are not aware there is something called directional property or directional OCT, if we see the image B here, we may think that there is hyperreflectivity of the OPL or thinning of ONL, or similarly in case of image C, we may think that OPL is hyperreflective and ONL is thinned out in the temporal side of the fovea. But in actual scenario, if we are aware in our practice that this may not be actual OPL hyperreflectivity or ONL thinning and it may be a result of directional property, then we will be able to differentiate these things from deeper retinal diseases like AMN, PAMM, and we need to take into consideration that whether we are actually dealing with hyperreflectivity of OPL, thinning of ONL, or we are simply dealing with a directional property of Henle fibers layer. We need to consider Henle fibers layer involvement in deep retinal diseases. Until now we saw directional property of OCT in a normal eye. Let us now see a directional OCT in a case of commonly seen disease in clinic, which is central serous chorioretinopathy. There is SRF at the fovea. If we look closely, the OPL marked by the red arrow appears hyperreflective, whereas OPL on the other side of the SRF marked with the green arrow appears normal. So this is not an actual hyperreflectivity or thickening of OPL which is there. Rather, it is Henle fiber layer which has become visible because of its directional reflectivity and because of the tilt of the retinal contour caused by the subretinal fluid, that it is visible on one side and not visible on the other side. Finally, it's not that directional OCT is only useful in imaging the elusive Henle fibers layer. It has also been utilized in assessing the integrity of ellipsoid zone and retinal pigment epithelium in eyes with AMD. So what are the two takeaway messages from this video? Directional OCT is not a new OCT system or anything. Rather, it is hardware independent. Directional OCT can be obtained on any SD-OCT or SS-OCT system. It's just that it's operator-based technique as of now, and the technician needs to be trained to obtain off-axis images to get the directional OCT. And we should be careful in diagnosing deep retinal diseases which involve ONL, OPL and INL. We should take into consideration that whether we are actually dealing with hyperreflectivity of these layers or its directional property or directional OCT. Hope you liked this video. Do share your comments and suggestions with us. Don't forget to subscribe to our channel. Thank you very much.